All right, people. So, no school today, but that doesn't stop AP Calc from happening. Because, we got to keep going in AP Calc, so we're ready for this test. So, first one, getting ready for the Khan Academy test. What is the volume of the solid generated when R is rotated about the y-axis? Okay, so we're going around the y-axis. Anytime we go around the y-axis, okay, we got to turn these y equals into x equals. So here, x equals y over 2 with the blue line. And here, if we multiply by 2 and take the square root, x equals the square root of 2y. All right, now we can see that this is the washer method because there's a blank spot in between this line and the y-axis. So the washer method integral from here to here, so 0 to 8, because we're going around the y-axis, so we got to measure in the y, and it's pi r squared. Okay, well, the radius is the outer one minus the inner one, so it's the square root of 2y squared minus y over 2 squared dy. Okay, so if we square them both, it's 2y minus 1/4 y squared dy. So what I'm going to do is just grab my graphing calculator and take care of it right now. Oops, I want to go here and here. Kaboom. All right. So I go math 9 and get the integral up. 0, 8, 2y minus 1/4 y squared dy. So that's 21.3 repeating. If we change that into a fraction, that is 64 thirds. So it's 64 pi over 3 is the answer. Washer method. Okay. Here's a curve that's graphed. When the area is bounded by the y-axis and the line y equals -1 and the line y equals 2, how many square units are there here? Okay. So what we're doing is we're going against the y-axis. We're not rotating. We're not doing anything like that. We're just looking for this whole area from here along here to here. Okay? So, since it's against the y-axis, we're integrating from -1 to 2. This is already solved for x. Yay! That makes it much nicer. We just do that. So, graphing calculator. Math 9, integrate from -1 to 2 of y cubed plus 8 dy 27.75. Easy peasy lemon squeezy. All right. The base of a solid enclosed by the graphs y equals this and y equals this between the y-axis and 4. Okay? So it's got a couple lines. Cross sections of the solid perpendicular to the x-axis where the height of the rectangles are this. Which one is the definite integral of solid? Okay. So I'm going to graph these on a graphing calculator quick, just so you can see what they look like. Clear. Clear. Go up. All right. 2 plus x over 2, and 2 raised to the x divided by 2 power. Ooh, my window's way off. Let's go zoom 6. Boom. There we go. There. And then we got that. Okay. So we're going to put rectangles in between there. So here's our axis. It's bounded by x equals 4 in the y-axis. So we're at 1, 2, and it's 1, 2, 3, 4. So we start at 0, gives us 2. 2 gives us 3. 4 gives us 4. So it's a straight line like that. And the other line kind of is curved underneath, crosses at 1. Because 2 to the 0 power is 1. And it kind of meets up right at 4 here. So we'll just kind of go like this. Okay. So we're perpendicular to the x-axis with rectangles. A bunch of rectangles here. Who have a height of this. Okay. So the rectangle is the area of a rectangle is the base times the height. So the height is represented right here. So we're good there. The base, the length of the base of the rectangle is the difference between these two, the top curve minus the bottom curve. Okay, top curve minus the bottom curve. So the top curve is this, the bottom curve is this. So this comes first minus this comes second. Well, looky there. It's this one right here. Okay. So top curve minus bottom curve from 0 to 4. The function b sub t gives the number of books sold at a store at a time in a given year. What is this telling us? Well, the derivative is the change in. So if we're integrating a derivative, then we get the actual number of books sold. We get the actual number of books sold between 45 and 50. Okay, because we're integrating a derivative. Okay. Now, if it's just a derivative, that's the change in the rate of selling the books. But this is how many books they're actually selling. Consumer surplus in the amount of money consumers will save because they are able to buy a product at a lower price than the highest price they would be willing to pay is given by this function. How many dollars in surplus will increase between 7 and 12? Well, we're going to integrate between 7 and 12 of 900 over x plus 13 minus 35. Okay? So if we're going to integrate that, it's kind of like 900 times the integral from 7 to 12 of 1 over x plus 13 minus 35. Okay? So if we integrate that, that's 900. The natural log of x plus 13 minus 35x. Because the integral of 35 is 35x. All right. So then if we stick a 12 in and stick a 7 in to these, 900 ln of 25 minus 35 times 12 minus 900 ln of 20 minus 35 times 7. So if we subtract these two, it's 900 ln of 25 minus 900 ln of 20. So if you subtract these two, it becomes a fraction of 25 minus 20, or 25 over 20, which is 1.25. Okay, so it's either this one or this one. So if we take 35 times 12, which is 420, 35 times 7, which is 245, and subtract those two, we get 175. All right, a particle moves along a straight line with a velocity v sub t graphed, where t is time in seconds. At t equals 2, the particle's distance from the starting point was 10 meters in the positive direction. What is the particle's position at t equals 9 seconds? So this was 2 in the positive direction. So at time equals 2, it's 10 meters in the positive direction. What is the position 9 seconds later? So that's the position is the integral of velocity. So we have to go from time equals 2 to time equals 9 seconds. And it was at 10, so we go with this one. Don't even worry about the graph so much. It's just the explanation where this comes from. Because we started at position 10, and then from 2 to 9, the velocity changed. And so if we integrate velocity, we get position. The base of the solid of the region bounded by y equals e to the negative x, this line right there, and the x-axis and the y-axis, and the line x equals 1. Okay? So if we have semicircles here, okay, there's my semicircles. So the area of a semicircle is 1/2 pi r squared, because it's 1/2 of a circle. Okay? Now, we got to figure out the radius of this. Well, the radius is half the distance from here to here. So the radius equals 1/2 e to the negative x. Okay? So we're going to integrate from here to here. Okay? So we go from 0 to 1 of 1/2 pi r squared, which is 1/2 e to the negative x squared. Well, I'm going to pull out my 1/2 and pi and just integrate from 0 to 1 of 0.5 e to the negative x squared on my graphing calculator. Oh, nope, not on my graphing calculator, because I have to determine the exact volume. So I'm just going to integrate then. I'm just going to use my brain, I guess. 1/2 pi. If we square that, it is 0.25 e to the negative 2x Okay, so if we put in 1/2 pi times, and we integrate. All right, so integrating e to the negative, let's just slide out that 0.25. If we slide out that 0.25, which is 1/4, then it becomes really 1/8 out here, the integral of e to the negative 2x. There we go. If we're going to integrate e to the negative 2x, it's negative 1/2 e to the negative 2x from 0 to 1, and that's being multiplied by 1/8 pi. So you take 1/8 pi, put it in the 1, so it's 1/2 e to the negative 2, put in a 0, e to the 0 is 1, so minus another negative 1/2. So it's plus a positive 1/2. So if you take 1/8 pi through there, come up here. So we get 1/16 pi times 1 over e to the second plus 1/16 pi. So, I don't know the best way to write this. I guess it's 1/16 e to the second minus 1/16 times pi. I guess that would be a way to write that. All right. The shaded region bounded by the function this and the x-axis. What is the area? Okay, so that's just simply the integral from negative 4 to 6 of 12 plus x minus 1/2 x squared. So again, throw that in our graphing calculator. On math 9, from negative 4 to 6 of 12 plus x minus 0.5 x squared dx. Enter 125. Uh-oh, none of those answers. 12 plus x minus 1. What is the area? Negative 4 to 6. Did I put it in my graphing calculator right? Negative 4, 6. Negative. Oh, forgot the squared. I thought I pushed x squared. Guess I didn't push it hard enough. There we go. Now we're cooking with Crisco. All right, 250 over 3. Boom. All right, next. Let R be the region enclosed by y equals x over 3, y equals 4 minus x, solid generated by this rotating around this line, x equals 5. We're rotating around a vertical line, so we have to change these into x equals. Well, this one is easy, x equals 3y. This one, that's fairly easy. We just switch the x and the y around. So x equals 4 minus y. And it's around x equals 5. So we have to find the distance from each, and basically there's a gap in between, so it's the washer method. So the washer method is pi r squared. So it's the integral of, we'll take the pi out, and we'll go the furthest one away, 3y, or we're going this to this. So 5 minus 3y. To find the distance between these two, we subtract. And when we square it, shouldn't make a difference. 3y minus 5 squared, or 5 minus 3y squared. Should still be the same thing. Minus this line. 4 minus y minus 5 squared. The further minus the closer. dy. So let's just throw that in the graphic calculator. Math 9. We're going from here up to here. So 0 to 1. This is not going to be a very big area. Volume. 0 to 1 of, we're going to throw an extra parentheses here, because it's basically this. So it's going to be 3y minus 5 squared minus 4 minus y minus 5 squared dy. Math, change it into a fraction, please. 32 pi over 3. Oh, this one's a fun one, because basically we got to find that point. And then we have to take the g function minus the f function here, and the f function minus the g function there. Okay, so it's a calculator one. So we're going to graph these. Whoops. Can't slide this over, so I got to slide my graphing calculator over, I guess. Boom. You go over there. All right. So let's go y equals. There we go. Clear. All right. Now we have the g function. We'll go first. So the f function is fine if we go first. 18 log base 10, and a log is log base 10 of x. This is the first function graphed. This is the blue function. The red function is 0.5 x raised to the third minus 8x squared plus 34.5 x minus 27 graph. All right, so we can't see everything, so we got to change our window. Let's just go like -2 to the 12. And here we'll go -2 to 20. And then we'll be able to see everything, because this one goes from 1 to 10 and 0 to 18. So, yep, there. We can see basically everything. We don't need to see the bottom of that graph. So, we first have to find this intersection to a whole bunch of decimal points. So, second trace, intersect, which is 5. Ooh, it's right there. Enter. And the intersection is right there at 4.50. So 4.506. 1649. So now what I'm going to do is go on my graphing calculator. And the first part, I want to take g minus f, so y2 minus y1. So I turn this off, but I don't delete it. Just turn it off. And I go y2 minus y1. I'm going to graph it. It's going to make a parabola between 1 and that other number that I just put up here. So I'm going to go second trace 7. My lower limit is 1. My upper limit is 4.5061649. Boom. And it's going to shade that area in perfectly. And I'm going to get 22.812 486. Now I'm going to get my other area. So I'm going to go y equals, change my curve, turn off this one, turn on this one, graph it. So I'm going to go second trace, I'm going to go 7, and I want to get it from 4.5061649 all the way up to 10. And I'll shade it in perfectly. Boom. So that's 81.831. Seven, 8. So then if I add these up, that adds up to 1, which carries a 1, which is a 4. So that's what I needed. And a 4, and a 16, and a 6, and a 10. 106, 106.644 to the nearest 3 decimal places. There we go. All right. Solid generated by rotating around the x-axis is pi r squared. So it's pi integral of the sine of x squared. And then we go from there to there. So from 0 to pi. So pi, 0 to pi, sine x, sine squared x, so 0 to pi. Oh, that would be the first one. All right. Region between these two graphs, you just graph them both. Handy dandy graphic calculator, graph them both. Y equals, clear this one, clear this one. Go down, turn off this one. Type them both in. X squared plus 2x plus 2. And then 2x squared plus 3x minus 4. Graph them. 1, 2. So we can't see, so we need to change our window. Let's go -10 to 12 and